Corporate finance practice problem using Excel. Convertible bond, the crossover point where the conversion value equals the pure bond value. Get ready, it's time to take our chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're in the practice tab as opposed to the example tab. The example tab, in essence, being an answer key. Information on the left, we're going to calculate that in the blue area on the right. And we're looking at our convertible bonds. Once again, those bonds that can be converted into some shares of common stock if the bondholder so chooses. The first couple calculations will be similar to prior practice problems. The new thing will be down here in the crossover point. So we might go a little bit faster in the first components and then get down here to that crossover point, the new thing we have. So the convertible bond outstanding market price is going to be the $950. That's what the convertible bond is selling for on the market for. Par value, $1,000. The coupon rate, 7%, matures in 24 years. The conversion ratio, meaning how many shares the bond could be converted into, would be 32 shares of the common stock. The common stock market price, meaning what the shares that they could be converted into would be, currently are selling for a market price of $19. The interest rate on bond that are similar but not convertible, yielding 13%. In other words, if we try to figure out or think about the bond side of things, to figure the value of the bond, it's difficult to do since we have a more complex security with this conversion feature. If we try to compare it to bonds that are similar without the conversion feature, that would be one attempt for us to approach the valuation of this more complex type of security. So we'll use that shortly. Let's take a look at the conversion value. The conversion value, this would be us trying to look at this bond from the angle of the common stock valuation, meaning if we converted to the common stock, what would be the value of the common stock? Because we know the value of the common stock because it's trading on the market and it's a more simplified, security. So we're going to say we have the conversion ratio, which was the 32. That's how many shares we can convert this bond into, the 32. And then we've got the stock price, which we said was the market price at the stock market price is going to be the $19. So we'll pick up the 19 and multiply that out. This is going to be equal to the 32 times the 19. That's going to be the conversion value. Calling that the conversion value. So if we took these bonds, converted them to stocks, they currently have that value of the 19 each, so the 608 in other words. The pure bond value, let's calculate that. We're going to be using the valuation of the interest payments and the present value of the endpoint, the $1,000 we would receive at maturity, assuming then that we didn't have the conversion feature and we're comparing to similar bonds that don't have that conversion feature. Now we're looking at the bond side of this kind of more complex security as if there was no conversion feature. So we're going to do that. These present values, note, we have seen these present value calculations with relation to bonds in a prior section. We did a whole thing on it. So if you want to focus in on that and get more practice with that, take a look at that section. Or if you want to look at present value calculations, you can look at our present value section where we have a lot more calculations on that. So we'll do this fairly quickly. Negative present value, PV, shift 9. We're going to pick up the rate, which is going to be the 13%. And these are going to be semi-annual bonds, so that's going to be a yearly rate. We're going to take that then, dividing it by 2 for the half-year or 6-month rate, comma, then pick up the number of periods. That's going to be the 24, but that's years, and we need 6-month periods, so we're going to say times 2 to get the 6-month or half-year periods, comma, the payment, which is going to be 1,000 times the 7%, but that would be payments for a year, that 7% being the yearly rate, and this is semi-yearly or 6 months, so dividing that by 2, that would give us the 512. Now we're going to take the present value of the maturity amount, the 1,000, that's going to be negative present value, shift 9. The rate is going to be the 13%. We're going to divide that by 2 once again, comma. The number of periods is going to be 24 times 2, and then comma, comma. Future value is going to be that $1,000 here. Going to say enter. Summing that up using the trusty equals SUM function, the sum function, the 512 and the 49 giving us the 561. Adding a couple pennies here by going to the number group, couple pennies added. Underlining the 4867, font group and underline. we got the 560.92 value of the bond for similar bonds if there was no conversion option. So now let's look at the conversion premium, comparing the price to what we calculated the value of the stock to be if we were to convert them to the stocks. So for that, we're going to take the bond market price, what the bond is currently selling for, which is the 950, compared to what we calculated the value of the stocks to be if they were to be converted at the 608. Subtracting that out, the 950 minus the 608 means we're paying 342 over the basically the conversion value of the stocks themselves, and that would be the conversion premium. So then we can do the same kind of thing with relation to the bonds here. We could say, all right, well, what's the comparison, the difference in the pure bond value and the market price? So the market price is still the 950, and the bond value for similar bonds that don't have the conversion is what we said was 560.92. So that I'm just going to call the difference is going to be equal to the 950 minus the 562. Let's put an underline there, font group and underline. Let's add some decimals to it, selecting those cells, number group, couple decimals. So then we can think about the crossover point. The crossover point being this kind of the new thing here, where the conversion value is the same or equal to the pure bond value, meaning if we measure both sides of this thing, meaning the value of the bonds on one side using the pure bond value and the crossover value of the stocks on the other side, we come to the same value. Let's take a look at that. We're going to say the crossover point can be calculated at the pure bond value. Pick up the pure bond value of the 560. We'll pick it up this way. And the conversion ratio, the number of shares we can convert into, is going to be equal to the 32 conversion ratio, underlining that, font group and underline, and that then is going to give us our crossover point, and that's going to be equal to the 561 divided by the 32. Let's add a couple decimals though. We're going to add a couple decimals to these three cells, go into the number group, decimalizing it. We've got the 17.53 for the crossover point. So if we looked at the conversion value at this point then, if we think about the conversion value with the price at the 17.53, we would then say, okay, the conversion value would be equal to the conversion ratio at the 32, and the stock price, we're going to say stock price, which we just calculated at the crossover point, the 1753. And that would give us the conversion value, meaning the value of the stock if the price of the stock was at that 1753, 32 times the 1753 if we add decimals, which we will do now. Number group, add a couple decimals. Let's put an underline under the 1753, underlining that one, and that should give us the same value as the pure bond value, which is here. The pure bond value. So there we have it, the 560.92 and the 560.92 matching when the price would be at the market price, which is not determined by the company, of course, could be at the 1753. So the last thing we could do is kind of calculate the interest rate and try to kind of figure out what the interest rate would be in order to meet the current price at the 950. So in other words, the market rate was at that 13. So I'm going to start at the 13. We'll come up to the same result, which is that 560, and then think about, okay, well, what would the rate be if we were at the pure bond value of the 950 here? So let's do that real quick. We'll do the same present value calculations. I'm going to get to the same point first, and then we'll adjust this number to get to the end number here being the 950, backing into that using our goal seek feature. So that's going to be the negative present value, shift 9, the rate 13%, which I'm going to pick up over here this time, divided by 2 because semi-annual, comma, number of periods is going to be 24 times 2 because semi-annual, comma, the payment is going to be the 1,000 times 7% divided by 2 because semi-annual. So same number here, same calculation. Let's do it again. Negative present value, shift 9, rate 13% divided by 2 because semi-annual, comma, number of periods 24 times 2 because semi-annual, comma, because it's not an annuity but present value of 1. And then we're picking up the $1,000 and enter. So there we have that. Summing it up equals the SUM, shift 9, picking those two numbers up. There we have it. Let's go ahead and add some decimals now by going to the number group, decimalizing it. So there we have that. Now let's underline the 4897. I've got a fly flying into my eyeball for some reason. Sorry about that. It was distracting. I blinked though and it went away. So there we have it. Now we're going to change this rate until this number gets to the 950, which is the current market value. So we could change that by just changing the rate like itself, or we can then go in here and use the goal seek. So we'll go to the data tab up top, number group, goal seek. I'm trying to pronunciate, but I'm scared the fly is going to fly into my mouth now. So then I can't, it's hard to pronunciate when you don't want to open your mouth. Well, so if I can't be understood as clearly as I used to, it's because it's the fly's fault. So in any case, we're going to say the cell, we want to set this cell to be the 950 by changing this cell. And then we're going to say OK. So there we have it, changing the rate then to the 7.45.